Hello, this video is in response to a question I received from a student asking about how to use Statcrunch to answer question number 5 from homework 3.3. So I'm going to walk through the steps for that and show you where to find the steps to do it in our Blackboard course as well. Okay, so here is the question that I'm going to cover today, and it is from section 3.3 in your book. So it asks you to use the frequency distribution that was obtained using a class width of 0.5 for data on cigarette tax rates, and use the frequency distribution to approximate the population mean and the population standard deviation, and then compare the results to the actual population mean and actual population standard deviation. So this problem has data that they've provided in this. We can click on the icon and we can see the data. And the easiest way to solve this is to use Statcrunch. So I'm going to go into Statcrunch with this. But before I do that, I want to just pause for a second and point out a couple things that's important. So when we talk about bins, they also use the word class. So sometimes they'll say bin width and sometimes they'll say class width. It's the same thing. And so basically that means we have a width of 50 cents for each of these different tax rates. And the standard is to have it include the lower number. And if these were the same, if they were both 0.5, we would only include the lower and we go up to the top one. But since this is 49 cents, we don't have to worry about that. So it's this entire range. The frequency listed here is how many of the tax rates are in that range from 0 to 49 cents. So we don't know what they exactly are. They're just somewhere in that range, which is why we're going to get an approximation if we use the bin data, because we don't know what the exact number is for those 7. Like for instance, for this last one, the tax rate was somewhere between $4 and $4.49, but we have no idea what it actually was. So that's one thing to pay attention to. Another thing is that we're being asked to calculate the population mean and population standard deviation. And whether or not things are a population or a sample is super important. And I tried to give you a tip to help you with this. And I've put the quick tips, I sent it out as an announcement and an email, but I've also made a folder in our video course resources area called quick tips. So if you go there, you'll see that there's a quick tip for week 3. Let me zoom this in a little bit. I link to a couple of homework videos that I use to show you how to use Statcrunch for some of this work. But then I also have this table. So the table is really helpful because it talks about if you're looking for a population mean or a sample mean, what the variables are. So the fact that this was mu instead of x bar lets me know that this is a population mean, and the population standard deviation because it's sigma instead of s. So that's also really helpful. But then also if we're using Statcrunch and we're trying to find the Statcrunch standard deviation, it's actually a different thing. It's unadjusted standard deviation in Statcrunch, and then sample standard deviation is just standard deviation. So this matters when we are making our choices in Statcrunch. So I highly recommend that you copy this table down into your notes. Okay, so then the next thing I wanted to show you was where we find the steps for Statcrunch. And so if we go to the Statcrunch how-to guide and we look at the steps here, so we're in section 3.3. So we can kind of cheat a little bit because we know which section we're in. If we didn't know what section we were in, we would have to think about what we're being asked to do. So we're being asked, mean is a type of central tendency. Central tendencies are mean, median, and mode. And then grouped data is another way to say binned data. And so that's how we know we're in section 3.3. So then we look down here and there's two options here that we have for the instructions: mean, standard deviation from from grouped or bin data. So that's what we're trying to do. And so now we're going to come over here and we're going to open this up in Statcrunch. So to open it in Statcrunch, we're going to click on this little table icon. You always want to try and find the table icon whenever you want to open something in Statcrunch, because when we do that, it will automatically open the spreadsheet with all of the data already filled in, including the variable names up here. So it not only gave us the bins, it also gave us the lower limit and the upper limit. And we don't actually need the lower and upper limit for this particular problem, but they're there. So we're just going to follow the steps on the left here. So we're going to select stat, and then summary stats, and then grouped/binned data. So the bins are, let me make this bigger so I can show the data at the same time. The bins are these tax rates. We're going from 0 to 49 cents. So that's tax rate is our bin, is where the bins are located. The counts, that's the frequency. So that's our frequency column. And we don't really need to worry about any of the other things here. It does say, let's see, counts in. It does say consecutive lower limits, so we'll go ahead and do that. And then we want to calculate the population mean and the population standard deviation. So mean is mean, but standard deviation for the population, we have to scroll down to unadjusted standard deviation. And to select them both, you're going to select one and then hit the control button and select the other. And then we're going to hit this compute button here, compute. Okay, so when I get that, I get a mean and a unadjusted standard deviation. So if I go back over here and type it in, this person was doing it by hand. Now, the mean that we calculate should be pretty close to the actual population mean, because the bin data still kind of is that the bins are pretty narrow. If the bins were really wide, maybe it would be a lot different, but they're pretty narrow. And it says to round to 3 decimal places, so 583. Well done. And then the population standard deviation, remember that means it's our unadjusted. Again, 3 decimal places, 1.096. Nice work. And then it asks us to compare the results to the values found using the actual data. So the actual data, the mean was $1.531. When we used the bin data, it was 0.583. So it was a little bit higher when we used our bin data. Same thing here, our population standard deviation was also a little bit higher. So we're going to say our grouped values, because remember bins are groups. So our group values are both slightly larger. And then I click check answer. So hopefully this helped you, and yes, good luck.